The Da Vinci surgical robot is the only FDA-approved commercial surgical robot that's in the marketplace. And I think it's taken the marketplace by storm. Part of the challenge with deploying new technology is that the training and accreditation for such systems has been a little falling a little behind. And so one of the things that our lab is looking at is trying to come up with simulation as well as a physical testing environment where surgical trainees as well as potentially surgical attendings can improve on their skills. The benefit of using robotic surgery actually accrues from using minimally invasive surgery techniques. So you now have a thin, long, pencil-like instrument that you introduce through a very small hole within a person's abdomen. And it lets you perform the procedure, and in terms of healing, you just put a single suture at the place where you enter, and the patient can go home literally in under 23 hours. So from the patient's perspective, they end up having less trauma inflicted on their bodies. From the surgeon's perspective, you're often sitting back. You're no longer standing over a patient, but you're now sitting back at a console and performing the surgery. And from a hospital's perspective, the fact that you're able to get patients home quickly now alleviates the problems of hospital-borne diseases. The Da Vinci was actually developed using a Department of Defense grant, and they had originally intended it for use in telemedicine applications. So what you see within the Da Vinci is that you have a master console where the surgeon sits and operates, and you have a slave console where you have the instruments that now enter into the patient's body at different locations. And these two are connected by a fiber optic cable. There have been experiments where people have done transatlantic surgery where the fiber optic connection is now replaced by a fiber optic connection across the Atlantic. There have been cases where this similar sort of surgery has been done on satellites using the same master console but performing repair operations on satellites. The challenge remains in terms of the communication bandwidth of the fiber optic connection. A lot of the surgical robotics and medical device industry has spurred a new revolution in innovation and entrepreneurship. There's a lot of interest in now creating end effectors for some of the new surgical robots. End effectors that give you enhanced dexterity within the patient's body. End effectors that will allow you to recapture the sense of touch, so the haptics. So one of the things that happens when you use a minimally invasive instrument is you compromise on your sense of touch. In being able to recreate that sense of touch, you have immense opportunity. And all of these are now being explored, promoting open innovation. And the energy and the enthusiasm around this, we hope will now help shorten the long development cycles that had hindered the previous generation of medical devices.